All right, welcome back. What we are going to do today is some more balancing practice. And so I gave these three problems for homework. And so I'm going to work on the first one right here. And I'm going to attempt to balance the equation. And to do that, I'm going to go ahead and draw out particle diagrams. And you notice this one is a little bit more challenging because we see on the left-hand side that the H's are in two separate spots, whereas on the right-hand side, it's only in one spot. And so this makes our balancing just a little bit more complicated. So what I like to do, actually, instead of drawing the particle diagram, I'm going to use a different method, and it's going to be called reactants. It's going to be a table. I'm going to have reactants on the left, I'm going to have products on the right, and I'm going to have atoms in the middle. And so I'm going to make a table, and I'm going to go ahead and list in our equation, I have an H atom, a chlorine atom, a barium atom, and an oxygen atom. And then we notice we have H here again, but because H is already listed in our list, I'm not going to repeat it. And then we notice on the other side, I have a barium atom, which is already on the list, a chlorine atom, which is already on the list, a hydrogen atom, which is already on the list, and an oxygen atom. So we see that all of our atoms are listed in the table. And so before I begin, what I'm going to do is go ahead and count on the right-hand side. So right now, I'm just looking at the atoms on the left-hand side. I'm looking at the atoms on the left-hand side, and I'm counting them. So I see one hydrogen, so I'm going to write a 1. I see one chlorine, so I'm going to write a 1. I see one barium, so I'm going to write a 1. I see two oxygens, so I'm going to write 2, and then also 2 more hydrogens. So 2 plus 1, this is actually going to be a 3. So I have on the left-hand side a total of 3 hydrogens, 1 chlorine, 1 barium, and 2 oxygens. And I'm going to do the same thing on the right-hand side. So I see I have 1 barium. In this case, I have 2 chlorines. In this case, I have 2 hydrogens, and in this case I have 1 oxygen. Now, why is a table like this useful for balancing chemical equations? Well, we can see very easily now that the only atom that is actually balanced is barium. There's 1 on each side. We can easily see that the chlorines are unbalanced. We can easily see that the hydrogens are unbalanced, and we can easily see that the oxygens are unbalanced. And so, instead of trying to juggle multiple things at one time, what I like to do is I like to just focus on one atom at a time. And what I'm not going to do is I'm not going to focus on hydrogen, because hydrogen is going to be the hardest one. And the reason hydrogen is going to be the hardest one is because it's split up into 2 different locations on the left-hand side. And that seems kind of hard. So what I'm going to do is not focus on hydrogen for now. Instead, I'm going to choose either chlorine or oxygen. And chlorine looks like it would be the easiest one to focus on. So let me go ahead and erase some of my marks so that this is less confusing up here. And so what I'm going to do is I'm going to use blue, and I'm just going to focus on the chlorine for now. And I notice that I need more chlorines on the left-hand side. So in order to do that, I'm going to put a 2 out in front. And when I put a 2 out in front of the HCl on the left-hand side, that changes my hydrogens to 4 in total, because I have 2 right here, and I also have 2 right here. It also affects my chlorines, and it makes my chlorines 2 in total, because this 2 goes also to the chlorine. And so now I see that I've fixed my chlorines. So now my bariums and my chlorines are perfectly fixed. So now, again, I'm not going to fix the hydrogens because that's the most complicated thing, and I want to do the most complicated thing last. Now what I'm going to do is in purple, I'm going to go to my oxygens, and I see I need more oxygens on the right-hand side. So I'm going to go ahead and put a 2 here. And then I'm going to think, how does that affect this table? Well, I see that it affects the hydrogens on the right-hand side. That'll change it to 4. 2 times 2 is 4. And then it's going to make my oxygens 2. And so now, when I go back, it looks like my hydrogens are balanced, my chlorines are balanced, my bariums are balanced, and my oxygens are balanced. So actually, all I need to do is put a 2 out in front of the hydrochloric acid and a 2 out in front of the H2O, and that fixed everything. So what we can do is we can use these types of tables called reaction, atom, and product tables, or RAP tables. And what I'm going to encourage that you do is make sure that the thing that is the most complicated to balance, always save it for the last thing to balance. Because sometimes by balancing the other atoms, you're able to balance that one as well.